happening within the Earth. We know that the planet's interior is divided into several layers: the crust, the mantle, and the core. The mantle, in particular, is home to many of the forces that drive the planet's tectonic activity, including convection currents that cause the movement of tectonic plates. However, what if there are other, less understood processes occurring deep beneath the surface that could generate seismic-like waves? Some researchers have proposed the theory that the disturbance could be linked to shifting magma chambers or cavitation in the mantle. Cavitation refers to the formation of bubbles or voids in a liquid due to rapid changes in pressure or temperature. In the case of the Earth's mantle, such shifts could potentially cause vibrations that mimic those of an earthquake. Moreover, there are other seismic phenomena, such as mantle plumes, that we don't fully understand. These plumes occur when hot material from deep within the Earth's mantle rises toward the surface, creating disturbances in the crust. While these plumes are not typically linked to major earthquakes, could they have been responsible for the anomaly detected by NASA's instruments? It's certainly an intriguing possibility, as it suggests that there might be forces at work beneath the Earth's surface that we've yet to fully comprehend. In addition, recent advancements in geophysical research have hinted that there may be more dynamic processes occurring within Earth's deeper layers than previously believed. The discovery of this earthquake-like event could be the first indication that Earth's internal geology is far more active and complex than we realized. Perhaps the planet's crust and mantle are undergoing changes that were invisible to our current monitoring systems until now. What if the disturbance detected by NASA was not the result of cosmic or geological forces, but was linked to some unknown underground anomaly? Some researchers believe that the shaking observed in this event could have been caused by forces within Earth's subsurface that have yet to be discovered. For example, there could be unexplored or hidden fault lines deep beneath the surface, or even phenomena like underground volcanic activity that have yet to be detected. In recent years, geophysicists have become increasingly aware of the possibility that there are hidden fault zones or tectonic structures beneath the Earth that have gone undetected. The fact that this event did not originate from any known fault line or volcanic activity suggests that there may be a layer of geological activity happening beneath our feet that we have simply not yet identified. The Earth's crust may contain more surprises than we realize, and this discovery might just be the first sign of something bigger lurking beneath the surface. This idea raises another important question. Could there be previously unknown fault lines or geological features that are triggering these seismic-like disturbances without causing the usual signs of an earthquake? It's possible that this anomaly could be tied to a new type of seismic activity that we haven't yet been able to detect or understand. This discovery, if confirmed, could be one of the most transformative moments in the history of Earth sciences, opening up entirely new avenues for exploration and research. The implications of an earthquake-like event with no known seismic source challenge the very principles that have guided geological research for centuries. If the disturbance is caused by forces outside of our current understanding, whether that be space weather, unexplored geological phenomena, or an entirely new class of seismic activity, this discovery would force scientists to reconsider the foundational models we use to study the Earth's internal processes. Traditionally, earthquakes are studied based on the assumption that they occur due to the movement of tectonic plates, volcanic eruptions, or other well-understood geological processes. This new type of event, however, introduces the possibility that seismic activity could be driven by forces that we have not yet fully understood or discovered. This could require a complete rethinking of how we classify and study seismic events. If seismic waves can be generated by previously unknown sources or interactions, scientists may have to develop entirely new models to explain and predict these phenomena. For instance, much of the seismic research today focuses on understanding the movement of tectonic plates, fault lines, and the dynamics of volcanic activity. This new anomaly suggests that there may be other forms of stress or energy release in the Earth's crust that are yet to be explored. It could also point to the existence of hidden geological structures, such as unknown fault lines or seismic pockets that have gone undetected until now. If this is the case, geophysicists will need to develop new tools and methods to study these hidden forces and phenomena that influence the Earth's crust. Such a shift in focus could lead to groundbreaking discoveries about the way the Earth's internal systems operate. In the past, we've relied on understanding observable geological markers to track and study seismic events. However, if seismic events can be caused by forces beyond the surface, it could reveal an entire dimension of Earth's internal systems that have been obscured. This could lead to the identification of new fault zones, previously unnoticed sources of seismic activity, or unknown mechanisms that influence the Earth's crust. One of the most intriguing aspects of this discovery is the possibility that